Have you ever just stopped and wondered what's really going on inside your computer? I mean, right this second. It feels like some kind of magic, but it's not. It's actually one of the most incredible management acts in the world, and it's happening billions of times every single second.
So picture this. You're in the middle of editing a video, right? That's hammering your processor. At the exact same time, you've got music streaming, your email is fetching new messages in the background, and ping, a notification just popped up. How does one machine with limited power and memory juggle all of that at once? What's stopping your email app from just, I don't know, scribbling all over your video project and crashing the whole system?
Well, the answer is this invisible hero that's working tirelessly behind the scenes. It's not an app you ever really open, but it's the one piece of software that makes opening every other app possible. We're talking about your operating system, the OS. And the best way to think about it is as the ultimate manager, the boss that keeps every single part of your computer working in perfect, orderly harmony. So what exactly is this manager's job description? Well, its main goal is to take all the complicated, messy hardware inside your computer and just make it all work together, seamlessly. So that's the textbook definition, but what does it really mean? Basically, the OS is the traffic cop, the resource planner, and the security guard all rolled into one. Every single program on your computer that wants to use the processor or touch the memory or save a file, it has to ask the OS for permission first. It's the gatekeeper that turns what would be total chaos into an efficient, stable system. Today, we're going to look at 3 of its most critical jobs. All right, first up, how does our manager handle dozens, sometimes hundreds of applications, all demanding to run at the same time? This is the art of multitasking. But to really get it, we need to understand a really important difference. And that's the difference between a program and a process. Think about your web browser's icon, just sitting there on your desktop. That's a program. It's just a passive file, a set of instructions, kind of like a blueprint for a building. It's not doing anything. But the second you double-click it, the OS springs into action. It loads that blueprint into the computer's memory and starts building. Now it's a process, an active construction project that's alive and actually doing stuff. And for every single one of these construction projects, our OS manager sets up a private, isolated workspace. Each process gets its own little bubble in memory. There's a spot for its code, a spot for its data and other things it creates on the fly, and a spot to keep track of what it's doing. It's like a perfectly organized, private office for every single task that's running. Okay, but here's the real kicker. Your computer has one main processor, or, maybe a few cores, but you could have hundreds of processes all wanting to run. So how does the manager pick who gets the CPU's attention? This is where something called CPU scheduling comes in. The OS has this super fast scheduler that's constantly switching the CPU's focus between all those processes, giving each one a tiny, tiny slice of time. We're talking fractions of a millisecond. It happens so fast that it creates this perfect illusion that everything is running all at once. But what does a fair schedule even mean? Well, it totally depends on the computer's job. For a giant server that's just crunching data all day, a batch system, the only goal is to get as many jobs done per hour as possible. But for your laptop, an interactive system, the goal is totally different. You want a super fast response time. You want it to feel snappy when you click something. And then you have something like a real-time system, like the one in a car's anti-lock brakes. There, the only thing that matters is meeting deadlines, because if you're even a millisecond late, the result could be catastrophic. The OS manager is smart enough to change its goals depending on the situation. Okay, so our manager is a master at juggling tasks. But where do all those tasks actually live? Well, that brings us to its second huge job, managing space. This all starts with memory management. Your computer's main memory, the RAM, is like a giant shared office building. The OS is the building manager. It's responsible for giving each process its own locked office, making sure it has enough space to work without bumping into its neighbors. And that, right there, is the whole game. You have to let all these different programs share one physical space without stepping on each other's toes. If one app could just accidentally write its data into another app's office, well, it could corrupt data, crash the program, or even take down the entire computer. The OS is what prevents that digital anarchy. Now, RAM is temporary space. The moment you turn the power off, everything in it vanishes. For the stuff you want to keep around, our OS manager has a different system, the file system. You can think of this as the manager's master filing cabinet, where all the permanent records are stored nice and neat on your hard drive. And this filing cabinet almost always looks like a tree. You've got a single main folder at the top, the root, and then other folders or subdirectories branch off from there. And inside those folders are your actual files. It's a really simple but incredibly powerful way to stay organized, and you use it every day, all thanks to the OS.
Okay, so our manager juggles tasks and it allocates space. But what about keeping everything safe? Well, the third job, and you could argue it's the most important one of all, is for the OS to act as a security guard, protecting the system from accidents and from attacks.
Protection is all about drawing lines in the sand and enforcing rules. The OS absolutely has to be able to tell the difference between what a program is allowed to do and what it's not. This is just non-negotiable for having a reliable and secure computer.
So, how does it actually do it? How does the OS build these digital walls that keep every process in its own lane? The answer is actually surprisingly clever, and it's built right into the computer's hardware. The OS uses two special little memory locations for each process. The first is called the base register. It just holds the starting address of that process's memory space. Think of it as its office number. The second is the limit register, which holds the size of that space. Now, every single time that process tries to access memory, the hardware itself checks. Is the address it's asking for inside its approved range? If it is, great, go ahead. But if it's not, an alarm goes off and the OS steps in and shuts that process down immediately. It's like having a guard at the door checking everyone's ID.
And believe me, this isn't just some theoretical problem. This kind of boundary checking is what prevents one of the most common and dangerous types of cyber attacks in history.
It's called a buffer overflow. Here's how it works. A program has a little box in its memory, a buffer, to hold some data. But an attacker is clever, and they send way too much data. This extra data spills out of the box and starts overwriting other important stuff nearby, specifically the return address that tells the program what to do next. The attacker replaces that address with a new one that points to their own malicious code. So when the program finishes its current task and tries to return, boom, it gets hijacked. This is exactly the kind of disaster that memory protection is built to stop. So let's just zoom out for a second and bring this all together. Juggling tasks, allocating space, protecting everything. Why is this invisible manager so absolutely essential to how we use computers?
Because honestly, without it, none of this works. The operating system is the silent, unsung hero that turns our simple mouse clicks into a perfectly controlled symphony of actions. It takes a pile of circuits and raw hardware and transforms it into the stable, responsive, secure experience we just take for granted every single day. So the next time your computer is just humming along, handling a dozen things at once without even breaking a sweat, just take a second to appreciate that incredible manager working behind the curtain. It's juggling billions of things every single second, flawlessly. And it kind of makes you wonder, what would happen if it ever dropped just one?